Hello everyone and welcome back. Today we are going to solve this question. A body of mass m and radius r is rolling horizontally without slipping at a speed v, and then it climbs a ramp up to height 3v square by 4g. The rolling body can be. Okay, first let's make the image. So it's initially rolling. We don't know what this is. I'm just making a circular thing just to represent a rolling object. So it has m comma r as mass and radius, and then it's moving with a velocity v horizontally initially. So it's moving horizontally with velocity v initially, and then it climbs a ramp and comes to a stop at this height, and this height is 3v square by 4g. Let us see what we can do. Now they're asking us what that rolling body might be. Now let us see what we can do. So we know, so basically the approach which we are going to use it, as it is pure rolling, even the rotational kinetic energy will get converted into potential energy. So I'm going to conserve energy. I'm going to equate the gain in potential energy to the loss in rotational plus translational kinetic energy. Now let us see how we do it. So yeah, let us assume moment of inertia as I. So moment of inertia is equal to I, and given velocity is equal to v naught, and as it is pure rolling, we can say that v is equal to r omega. So yeah, so let us calculate ke translational. That is going to be 1 by 2 mv square, simple formula which we know, right? 2 mv square. Okay, and now let us calculate ke rotational. For simplicity for purposes, let us assume I to be kmr square, just like this. This is going to be simple, and k rotational is going to be 1 by 2 I omega square, but we know that we took I as kmr square, and we know that in pure rolling v is equal to r omega. V is equal to r omega. So omega is going to be omega is going to be v by r. Now let us put this value. So we get ke rotational is equal to 1 by 2 times I is k mr square, and omega square is v square by r square. Alright, so r square and r square cancel, so we get ke rotational, that is rotational kinetic energy, is equal to 1 by 2 k mv square. That's it. Okay, so total kinetic energy is going to be translational kinetic energy plus rotational kinetic energy, so which is going to be 1 by 2 mv square plus k into 1 by 2 mv square, which is 1 by 2 mv square into 1 plus k. Okay, but we know that energy is conserved in pure rolling. The friction doesn't do any work, it doesn't change the kinetic energy of the rolling object. So we will equate the loss in ke to gain in potential energy, in gravitational potential energy to be specific. To gain in, I'll write it as GPE, gravitational potential energy. So in the question, what height did they tell us? It went till 3v square by 4g. Okay, so potential energy gained is equal to mgh, we know, but h is equal to 3v square by 4g, right? So we get mg into 3v square by 4g, which is 3 mv square by 4. The g and g cancel. Okay, now we have 1 by 2 mv square times 1 plus k, which is the total kinetic energy, we have derived it, is equal to gain in potential energy, 3 mv square by 4. Now we need to, let us find the value of k. The masses cancel out, v squares also cancel out, and the 2 cancels out, and we are left with the 2 here. So we have 1 plus k is equal to 3 by 2. So therefore we get k is equal to 3 by 2 minus 1, which is equal to 1 by 2. So as k is equal to 1 by 2, the moment of inertia of our body is 1 by 2 mr square, mr square by 2. Now we know that moment of inertia is moment of inertia of which object is mr square by 2. We know that moment of inertia of a disk, of a circular disk, is going to be 1 by 2 mr square by 2. So therefore we can say that the object is a circular disk, and we are done.